Well, welcome everybody. It is great to see you all here. Thanks for coming out. I also want to say a special hello to all our friends who are tuning in over the live stream. Hello, friends. It's really cool. As far as I know, this is the first time a droidCon has been streamed live so that folks all over the world can, participate in real time with us and be part of the event. And I know that it's only with a lot of hard work from Touch Lab and Slides Live that it's possible. So maybe we'll give them one more round of applause. Okay, my name is Chuck, and I am the lead for the mobile engineering team at MapZen. MapZen is an open source mapping lab. So what does that mean? We build tools and software for location-based apps, and we also collaborate with other companies and organizations and governments on open geodata initiatives. I'm also a longtime Android developer. Some of the first applications I ever built was for my Motorola Droid with the slide-out keyboard from Verizon that came out. That was running version 2 of Android, Eclair, for those of you keeping score at home. And then I also did a lot of early work on the Samsung Galaxy Tab, the first gen that was the Android tablet before Android for tablets was a thing. And so that was really interesting as well. And so Android's come a long way, and testing in particular is an aspect of it that I've personally been interested in for a long time. And so normally, I've also given many talks about testing on Android over the years, and normally this is the point in the presentation when I would get up on my soapbox and try to convince you all why testing is important and why you should care about it. But I don't really feel like I have to do that as much anymore. One of the nice things about Android is it seems like over time, testing has become more part of the mainstream culture and more easily integrated into our workflow as developers, which is really great to see. So instead of focusing on the why should you be testing aspect, I'm going to focus a little bit more on the how aspect of it today. And in particular, I want to explore how we can actually design, from an architecture standpoint, our applications to make our code a little bit more maintainable, a little bit more readable, and also more testable. And so really testing comes down to an issue of quality. We as software developers, we want to ship things that do what we think they do and don't give us unexpected surprises. And having a robust suite of tests, unit tests, integration tests, acceptance tests for our applications can help make that possible. And so as I said, testing on Android has come a long way since the early days, and we have a lot of options now. But also with a lot of options, you can sometimes get into sort of an analysis paralysis situation where it's like, oh, there's too many flavors of cereal. I don't know which one to buy, right? Do I want the Honey Crunch or do I want the cinnamon? I don't know. And so we have a lot of different tools available for testing on Android now. So what I want to do is zero in on a few of them and talk about how I think we can best leverage the layout of our application and where we can best leverage tools for the different pieces of our apps. So another thing that's kind of come into play more recently in Android development culture is that of clean architecture. Now, the whole concept of model view controller or model view presenter or model view view model is not new in the realm of software development, but it's been in the last year or two that it's really kind of taken off in Android, and lots of folks have become interested in, oh, how can I apply these patterns, these architectures that have been around, have been tested, have matured over time, to Android development, given the special snowflake that it can be. But before we get into all that, let's take a step back and talk about, kind of how building our applications has evolved over the years. And so really, I think the logical place to start is with an activity, because, when I first started doing Android in 2009, and even today, when you're going to build an app, typically we're going to start with an activity, and that's our basic building block. And so what does the activity do? Well, it has a lot of different responsibilities, one of which is it's your gateway to the operating system, the Android platform. So your activity is also your context. And so one of the things the activity does is it handles incoming lifecycle events, things like onCreate, onDestroy, that occur when the user launches your app or rotates the device. It also provides you access to other services on the platform. So you can hook into system services like the location manager or the layout manager. or the package manager. And that's kind of your way to dive into and interact with the environment that your application is running in. And well, naturally, we're going to want to have some sort of user interface to our app. And so, for example, we'll throw an edit text and a button on here and say, okay, well, that's going to be the elements that make up the starting screen of our basic application here. And as often apps will want to do, they're going to want to contact some remote service over a network, and they're going to want to get some data from it, and then maybe they're going to want to persist that data on the device in local storage. And by now, we all know as good developers, we don't want to block things on our UI thread and prevent our users from interacting when we're running tasks like that. So we were given this construct async task to bundle that up and make that all possible for us and do it behind the scenes. And then along came fragments. And so I was mentioning that I did some work in pre-Honeycomb on tablets before fragments existed. And when Android officially rolled out support for tablets, then we had this new UI construct, sort of a sub-activity of a more reusable component that could be used for different form factors, different orientations, and make things somewhat easier to reuse and reshape your app without having to write it all over again. Along with fragments, though, also came the idea of the fragment lifecycle, which added a bit of complexity to what we had to manage as developers, right? So now we have not only the activity lifecycle interacting with our application, but we also have the fragment lifecycle. Add on top of that, we can't forget our users are actually actively engaged with our app, entering input, typing text, clicking on buttons, swiping through views, and we probably want to make sure that the input they're giving us is actually makes some kind of sense in the world of our app, so we're going to need to do some sort of input validation. And then if the user happens to rotate the device while all this is going on, everything's going to blow up. But the thing you need to worry about most is if you have some long-running task in the background, we need to hold on to that. And so one approach for that would be retaining the instance of your fragment so that when your activity is recreated, you have the same one and it still has the connection to that async task. And then if we wanted to enter some other flow in our app, we would fire off an intent and parcelables, attach a bunch of parcelables as extras to tell that other activity what it should be doing. And then at the end of the day, we're going to say, okay, let's write a test for all this. And so we were given this construct, the built-in testing framework that came with early versions of Android was called Activity Instrumentation Test Case 2. That's a true story. And, and essentially what it did is it would spin up a process that would be, you would have a test harness and your code running inside the same process on either an emulator or a device. And your test code would then poke and prod your application, giving it some inputs and some stimuli on the device or on the emulator, and then sense what the outputs were and see if it was doing the right thing. Well, when you have so many layers going on like that, it can make it really difficult to figure out if you have an error exactly where it is, to make sure everything's working in concert, not to mention the time it would take to build your app and actually deploy it onto a device or an emulator, which made testing really kind of slow and kind of hard to get into any sort of unit testing flow. I really love this quote because I think it sums it up from Israel Ferrer, who, if you think about it as a burrito, what if you go through the whole line at Chipotle and you say, oh, you know what, I changed my mind, I don't want guacamole anymore. Well, there's no way to take it out. You're going to have to tear it apart and build you a whole new one from scratch. And that's kind of where we were with our applications. If we wanted to modify one of those layers inside, it had ramifications throughout the entire app. So, is there a better way? Well, going back to our initial example of the activity, as a first step, wouldn't it be cool if we could just take some of that logic that was living inside of our activity, some of that business logic that isn't specific to Android, but is more like your, the logic of your platform or your business, and pull that out so that it's not mixed in with lifecycle events and system services and callbacks from async tasks and things like that. And well, if we're going to pull out our logic into a separate entity, why don't we just take it one step further and pull out our data as well so that our logic and our data have clear separation of concerns? Sounds good, right? this is where a lot of the clean architecture patterns would start from these three objects. But in the Android world, I find it useful to think of your views as a separate entity as well. As Android development becomes more complex and we start to develop more dynamic applications, our views become equally more complex, and so does our view code. And so you have things like fragments, if you're into that sort of thing, or compound views, or overlays, dialogues, things like that. And so all of these can start to incur enough complexity themselves that I think it's useful to think of them as a separate thing from your activity and not just a member of it. And then so we get to the point where it's like, okay, well, if we want to apply some principles of clean architecture to this, now what do we call these things? Well, we could, going with the MVP example, or I'm sorry, the MVC example, we could call our model, naturally the data wants to be the model, right? We could call the logic the controller, but then our activity becomes our view. But then we also have a view. So we have a view talking to a view. Well, that doesn't feel quite great. Same thing if we go with model view presenter, right? And so we're still in this conundrum where we're calling our activity the view, but our activity is also interacting with other things called views, and they kind of have different responsibilities. Like one is more caring about the life cycle, the other one's more caring about the UI. Same thing with model view, view model, and I'm not trying to say that these are all the same pattern. There's actually a lot of nuanced differences here, especially in the way the flow of information works. But again, we're trying to apply this, this concept of 3 entities to really a 4-entity system. And then you get into, so I said maybe we can hack this a little bit, and we have our controller and our subcontroller, and that's what we call the activity, and that's what we call the logic, but that didn't really feel great either. And so I'm reminded of this great quote from Phil Carlton, which has been added on over time. The original quote was just about cache invalidation and naming things, and then somebody cleverly tacked on errors off by 1. But naming things is really hard, right? And it matters because that's like how we mentally construct, the mental construct we used for our applications affects the way we write our code. And so I said, well, who says you're only allowed to have a presenter or a controller? What if we have both? And so I started experimenting with this sort of layout here. What if we call the logic the presenter and the activity the controller? And then still have our data as our model and our view as our view. And this way we get rid of that confusion of the overloaded term of view, and we have a clear name for these 2 pieces. Well, and then taking it one step further, I said, okay, well maybe the activity is not actually going to be the controller, but it's going to implement an interface of a controller. And this is going to become important later on when we get to the testing portion. And now when we start to add back in all those other moving pieces that we saw in the initial diagram of the tasty burrito, we can see now we have a much cleaner layout as far as which of our core components cares about which one of these peripheral things. Our model cares about getting our data, whether it's over a network or whether it's out of a database. Our presenter is purely concerned with logic. Our activity is our gateway to the Android framework, as it always was, dealing with things like the lifecycle and the system services. And then our view is off by itself, and it can do things like validate the input and not necessarily send it through the whole system. If it's going to be something that's going to lead to an error anyway, we can just head that off right away. Like we have an empty edit text, we can just throw up an error before we even pass that to our controller or our presenter. What this does for us now is we have a very nice clean line where we can just draw right down the middle of this diagram and say, boom, everything on this side cares about Android, and everything on this side is completely Android agnostic. No dependency on the framework whatsoever. And so everything in green you see here has dependencies on Android, whereas everything you don't is just pure Java or Kotlin or whatever you like to write your apps in. So now how does this enable us to test? Well, so we're really going to be looking at 2 different strategies, one for testing the Android half of our system and one for testing the non-Android half. And so when we want to write tests for the non-Android half of our system, that's actually really where things start to, where we really start to reap some of the rewards of setting up our code this way. So what we can do is we can just take out all the Android components. The activities are gone, the views are gone, we don't care about the framework, we don't care about the life cycle. And we take that interface that our activity was implementing of the controller, and we use that to develop a dummy or a fake or a test controller that doesn't actually interact with the system. And that's the one that our presenter interacts to in our test environment. So with this, I'm talking about running just pure JUnit tests in your local JVM without any special tools to account for the fact that this is an Android app. Down in the bottom corner there where you see our web service and our storage, we're going to want to mock those out as well. One option for this would be to use Mockito. You could also write your own test doubles that you swap in your test harness. And what this will do is it'll make sure that we don't violate any of the unit testing rules, because there are rules, you know. This is a handy set of rules that Michael Feathers originally published in 2005 in a blog post, and then was part of his later book about working with legacy code. And you can see right away that if we kept a live connection to the network or a connection to an actual database, we'd be violating the first two rules of what is a unit test and what is not. And so we want to absolutely avoid that, and that will make sure our tests are more reliable and run faster. And so now we have our presenter and our model in isolation. I did want to make one note about the fact that we're using thread here instead of async task, and how that affects our test environment. So in the original example, we were using async task to contact the network and to interact with our storage. Now that we're in the non-Android half of our architecture, we can't rely on async task without polluting it with Android dependencies, right? And so we're just going to use thread instead and make sure that when our callbacks run, once our data is returned to our controller, it's always going to have to run things on the UI thread. So it just requires a little bit more attention to detail when you handle the data that's coming back. But when it comes to testing, what we can do is we can actually, if we put our implementation into the thread class, and I'll show you this a little bit later when we get into some sample code, you can, instead of starting the thread, because testing concurrency is always a nightmare too, especially in unit tests, that might even violate one of the rules. Wait, let me check. It doesn't specifically, well, actually it probably does, because it says you can run it at the same time as any of your other unit tests. If you have a bunch of concurrency going on, that can cause all kinds of problems. So that would violate another one of our rules, but if we just don't ever start our thread, but simply use the run method, which is what gets kicked off when you start a thread anyway, you can execute your code synchronously, talking to your mock service. So now, what does this look like when we want to attempt to test the Android half of our application? Well, this is where it gets a little bit more tricky, and we're going to need some additional tools, because we do have to deal with that dependency of the Android runtime environment. And so there's several options available out there. So Espresso, which I'm sure many of you are familiar with, is a popular framework for testing your views and your activities, still operating on in a device or an emulator environment, but not nearly as difficult to work with as the original activity instrumentation test case 2 was. And then another option would be to use UI Automator. This is a little bit better if you want to test how your app interacts with other applications. The tool that I prefer personally the most is Robolectric, which allows you to still run your tests in your local environment, meaning on the JVM. You don't have to deploy to an emulator or a device. And what it does is it simulates or mocks out portions of the Android framework that would rely on system components that don't exist. It uses a lot of the actual source code from Android and then just stubs things out at the lowest level possible. And so rather than having the Android actual real lifecycle methods coming into your activity when it's under test, you're going to have Robolectric kicking off of those lifecycle methods for you. If you go out to the runtime environment in your tests and you ask for a system service, you're going to get a mocked or a shadow version of it, is what they call it. And then as far as the stubbing out the presenter, this is something you can do, but you don't necessarily have to, because the presenters are just pure logic anyway, so there's no like nasty dependencies we have to deal with on that side, aside from the network and the database. But it can be useful if you still want to test things in isolation to just throw in a stub example of your presenter in there in the test harness. Then this also allows us to test our input validation in isolation as well through some series of simulated inputs. Okay, so let's look at some code. So I guess I'll show you it running first, and then we can take a look at how it works. Oh, that's interesting. How did my emulator get so zoomed in? Let's just try redeploying. Ah. Oh, from the corner? Oh, there it was. Yep. Cool. Thank you. Told you I was going to be fumbling around on a Mac. All right, so I adapted this example from the login flow template that we get as part of Android Studio. So when you start a new project, it gives you all those different options to choose from. This is one of the flows that is pre-baked for you. And so I started working off the login template, and right away it generates you like a 700+ line activity that does everything that Tasty Burrito likes to do. And it was delicious. And so what I did is then I started to kind of tease that apart and try to break up the different pieces of it into the model view presenter controller, or MVPC. And so all this does is, all right, so I'll give you a quick demo of what this actually does. And so we have two fields here. We've got the input for the email and the password, and then a button to execute the sign-in. If you try to sign in with nothing, you're going to get an error that this field is required because it's empty. So if we put in some input that doesn't look like an email address, it's also going to yell at us for that. Now we give it an actual email, and then if we give it a junk password, it's going to run. It's not actually going over a network right now. It's sleeping for 2 seconds and then comparing to some dummy credentials that are hard-coded. But I thought this was good enough to give us a working example. Okay, so it's going to come back and say the password's incorrect. And then if we enter the actual password, which is hello, don't tell anybody, the app just finishes, or the activity finishes rather, assuming that you'd be firing off some intent to go start your real activity once the user is authenticated. Okay, so I didn't actually preserve the original code that was spit out, but you know, trust me, it was very burrito-like. But what I did do is I have up here what it looked like after I got done teasing it apart. So let's just look at the Project Explorer here real quick of how the code is laid out. So you can see inside of our source main Java, I created 4 different packages for the MVPC architecture. And then, so the only thing that existed at the beginning here was the activity, which is here, and is now down to, instead of 700 lines of code, we're down to 95 lines. And you can see what the activity does. Well, first and foremost, it implements our controller interface, which does 3 things. And these are going to be the methods that get called back by the presenter when any logic operation completes. These are also the 3 methods that are going to be our interface that we want to test when we write our unit tests. And so the activity itself is a very thin facade for simply shepherding input that comes from the view and sending it over to the presenter, and then listening for callbacks from the presenter when some operation completes. So we've got 2 main components to our view. We've got the login form, which includes both of the edit text and the button, and then we've got the progress view, which is the alternate view that shows while the request is executing. And so the only thing that, besides handling the lifecycle events, the only thing the activity does now is it decides which one of those to show at any given time. So if we look down here, we've got when we show our progress, and you can see here where I'm wrapping things in run on UI thread. That's because we're getting callbacks from our simulated network connection, and we don't want to try and touch the UI from a background thread. But you can see here we're just toggling the visibility of the login form in the progress view, and then we're actually passing things on to them. So for example, when we get down here to show error and show success, the activity isn't actually manipulating what that error state looks like. It just says, oh, hey, login form, by the way, show an error, the authentication failed. And then the login form, the view, is in charge of actually figuring out what that's going to look like to the user. So let's take a look at the view next. So I'm a big fan of compound views where you extend some sort of layout file and then shove a bunch of other things in there that work in concert. And so that's exactly what we're doing here. We have a scroll view that wraps around our email view, our password view, and our sign-in button. And you can see that all this does, well, so it does a couple things. It takes care of the input validation, and so anytime new text comes in, it's going to, or rather anytime the sign-in button is clicked, you can see here we have the listener. Rather than just immediately firing off back to the activity and saying, yep, sign-in button was clicked, first we're going to check and make sure that we have the input that we have in our text fields actually makes some sort of sense. And so when the button gets clicked, we go to validate input. Validate input actually wants to make sure that the password's not too short, that your fields aren't empty, that your email address has an @ symbol in it, and all that good stuff before it actually calls on click up to the activity. And so the activity is just setting an on-click listener on this entire view. And that's what gets invoked once the input passes the checks. Okay, so now let's look at the other side of it. So on the non-Android side, let's jump over to the presenter. And so the activity registers itself with the presenter as a controller. Let's see, where's that happening? Yeah, right here, register. And so what that does is this gets called each time, not only when our activity is initially created, but this is also our mechanism for handling things like configuration change. So when the activity gets destroyed and a new one is created, this presenter is going to persist. It's going to live on. And the new activity that gets created in its place in landscape mode then needs to say, oh, hey, presenter, by the way, I'm the new activity. You should send any callbacks to me. The old guy, he's gone. We shipped him out of here. I'm in charge now. And so that's what register does. And so at the moment when we register, we want to check and see if we actually have a request out there, because that affects the state of our view. And so we want to check here and see if the account validator is currently in action. And if it is, account validators are modeled, by the way, and if it is, then we want to show the progress view. If it's not, then everything is cool and we just show the normal login form. And so this allows us, gives us a handy facility for dealing with things that have notoriously been tricky on Android, like configuration change. And then we have the on login button click, which is another form of input coming in from our controller, which then, so you might say, well, why don't we just, in the activity, when the form gets clicked, why don't we just show progress there? Why do we call it over to the presenter and the presenter calls back? Well, this gives us nice clean separation of concerns, which is good. If one of these things changes, the other one doesn't necessarily have to change. And then two, when we go to test it, we can test that it's doing the right thing in isolation. So the last piece I want to look at real quick here before we look at the tests is going to be the actual model. So we have an account validator class, which you can see doesn't do a whole lot besides instantiate an account validation thread and starts it up. And it gives you some method to check whether or not it's currently running. The validation thread is the one that actually does the work. And so this is where we simulate our network connection. And I abstracted that away. Again, this is going to come in handy when we do the testing into this network interface, which, for all simplicity's sake, has one method to connect to it. And then our simulated network connection is just going to sleep for 2 seconds. But we don't even want that to happen when we're running tests. We want to completely cut that step out. And so it's important to have that behind an interface. Okay, and then what it does is after it does its simulated transport time, then it just checks against some dummy credentials to see if it matches our canned usernames and passwords that we're willing to accept. Okay, so that's the app. Now, the test for this, they live over here in the test folder. You can see break down into the same architecture. I didn't quite get finished with the controller ones. I promise they're coming. I'll commit them tomorrow. They're almost ready. Isn't that what every developer says? So since we're already looking at the model right now, let's look at the model test. And so you can see here, this is where we're actually mocking out that network class, or interface rather, so we don't actually have to run the 2-second delay when we run this unit test. And so all we're doing here is we're making sure that we actually do call out to the network, but we don't want to really do it in our test environment. And so if I run this real quick, let's see what you have to do to run a test on here. Not command click, command shift R, nope. Command R. All right, anyway, you have to trust me that this runs really fast. Over on the side here, right click. That means command click in Macworld, right? Control click. Oh, that's what I'm doing wrong. Thank you, guys. If it appears that I don't know what I'm doing up here, it's because I don't. Boom. Okay. There you go. So we're not hitting the 2-second delay. We can, and you can imagine how valuable this would be if we actually were hitting a real live network connection and not just sleeping for 2 seconds. Okay, that's what I wanted to show you there. Then on the Android side of things, and so you can imagine we write a whole set of tests here for the different scenarios to make sure that the correct accounts are validated and the incorrect ones are not. On the Android side, I'm going to go pretty quick here because I think we're running short on time. Let's look at our view test. And so this is where, instead of the typical JUnit test runner, we're going to kick in Robolectric, and we're going to give it a little bit of extra information so it sets up our environments correctly. It's not 100% supporting API level 24 yet, so we're going to simulate API 23 when we run our view test. And then we can interact with our app as if it was actually running on a device or an emulator, but with the added bonus of not having the extra time of building it and deploying it. And so we can have this nice security of this test suite, which is going to verify that as we iterate and make changes to our app, that it's not going to break our existing logic. So here they are running down the bottom there. Now you can see this takes a little bit longer, especially the first time you run it, because we're actually downloading the Android jars right now and a bunch of other dependencies to run against on the local JVM. Whoa, where'd you go, Studio? There we go, and our test pass. So let's take it back over to the slides here. So this is all on GitHub. You can take a look at it there and yell at me for not finishing the controller tests. Or you could submit a pull request for them. So yeah, it's on my GitHub, ecgreb/mvpc. I also wanted to mention one other project that I've been working on over the last year or so, and this is a MapZen project called Eraser Map. This is the actual project, and my coworker Sarah's in the back there, that we were working on that led us to come up with this architecture, because we were like, there's a lot going on. So it's a mapping-based application, and the idea is it's all built using entirely open source software and open data, because that's kind of our thing. And you can imagine with mapping applications, there's a lot of overlay views where you have, the map is almost always the center focus, but you have different things that want to come over at a time, search results, driving directions, suggestions, things like that. And so we were just piling, views and fragments and activities on top of each other and giving things transparent layouts, and it was kind of insanity until we said, okay, well, let's try and figure out how we can use clean architecture. So this is literally the app that drove us to come up with the MVPC way of doing things, which worked great for this. I'm not going to say it's the silver bullet for any application. I'm always an advocate of picking tools and patterns that are appropriate to your use case. But for us, that was definitely the best one. And so Eraser Map is available on the Play Store, and it's also open source, so you can find it on the MapZen organization in GitHub. If you want to see an actual version of like a fully fledged app with this pattern in action. And then the last thing I wanted to mention before we wrap it up here is that we've been rolling out the latest version of our Android SDK this week. And so we've been working on a series of blog posts talking about all the new features that if you're interested in location-based apps or mapping from kind of a different perspective, a little bit more stylable, a little bit more customizable, I hope you'll check it out. And that's on the MapZen blog. And that's it. So do we have time for questions? I'm not sure. Yeah? Okay. I'll take a couple questions. Yes?
So how do you make sure that the presenter survives configuration change?
So the question is, how do you make sure the presenter survives the configuration change? And the way we do that is just we don't tie it to the activity lifecycle. We use either dependency injection or a singleton or some way that the activity gets the reference to it, but it's not owned by it. And then when a new activity is created, it just simply re-registers with that same existing presenter. So it's tied to your application lifecycle or your process, but not your activity lifecycle.
So if you have multiple views that are the same view but represent different data, so they each need their own presenter?
Yes, you could do that. And we definitely had some compound views that got so complex that they each had their own presenter. And then I didn't want to get into that rabbit hole as far as like from diagramming perspective, but you'll see it if you look at the code in Eraser Map, we do have multiple compound views that each have their own presenter. And then you get into a situation where sometimes the presenters want to talk to each other. And I found the best way to handle that is that's when we use an event bus. And we'll just have that be our communication vehicle between the different presenters, if it's needed. Yeah. Thanks. Yes?
Do you have any rules of thumb on what goes on the view versus the controller? Because, for example, I think you said you had a field validation in the view. Like, could you have put that in the controller? Or, I mean, is there any point where, like, were there any cases when you were like, this might go on both here and up there, view versus controller?
Right. So the question is about what should live in the view versus the controller when it comes to things like input validation and maybe the logic to show and hide which views are currently visible. And so what I always try to do is get as much out of the activity as I can, get as much out of the controller as I can, and make it as small as possible. Just because once you're dealing with the life cycle and you're dealing with fetching handles to the other things that contexts care about, I find that that's enough in there already that I don't want to put anything else in there. And I also think it's nice that a view knows how to kind of maintain itself as far as, and like was brought up with the last question, if the view starts to get too complex, then you might want to create a presenter just for your view. Yeah.
What about dependency injection? How do you preserve the presenter when you dependency injection?
With dependency injection, it's actually even easier. So like using Dagger, for example, I would just make my presenter a singleton and then use field injection to put it into my activities since we don't have access to the constructor. Yeah, sorry, that was about if you're using dependency injection, how do you manage the presenter? And I would just have it be a singleton that gets field injected into your activities.
I guess I had two questions sort of related to that. One is, if they're a singleton, do you worry about, or can you clean them up so that if you leave the screen, they're not hanging around in memory forever for the application lifecycle or the process lifecycle? And then the other one is, again, if it's a singleton, what if you had multiple of the same screen on the backstack? So like you have like a place marker from a map, and then you have like similar places, and then you go to another place screen. That would be the same screen, would need a different presenter. The same type.
Okay, so let me answer the first one first, and then I'll maybe need you to clarify the second one. So with how do you clean up your presenters, right? And so if you're just relying on the lifecycle inputs from the system, so like in our basic example, if the activity was destroyed when the new one was created, it would register with the presenter and it would persist, right? But if there was some logic that actually led to like wanting to intentionally shut down that activity because we were either starting a new one or finishing the application or whatever, then you could have some logic in there to actually shut down the presenter. So I would probably just expose a method on the presenter to tear it down and then the activity would intentionally call that when it was time to move on to the next piece in the flow.
Yeah. Like it is finishing or something.
Yeah, exactly. But we wouldn't want it to be something that automatically got kicked off by the system. We would only want to finish it off if that was like the user's intention. Yeah.
Yeah, I'm just thinking like but if you like back out of an activity or something, back to a previous screen, and you'll never get back to the presenter for that screen ever again, but it's still sitting right in memory.
Right. So maybe you'd want to like override your on back pressed or something like that to catch that and to differentiate that versus a configuration change.
Right.
Yeah. Good point. And then the second question was about if you have multiples of the same view stacked up and they each have their own presenter. I would probably go, I'm trying to envision a scenario where that would actually happen.
So you can imagine tapping like a location from a map pin or something. So that was a location screen, so you have the location screen presenter.
Right.
And then you have like similar locations on that screen. And then you tap into another location from that one. So you have two different locations on the backstack of the same type.
Yeah. I mean, I guess you could handle it with a presenter that knows how to manage more than one view registering with it, or more than one controller registering with it. Or you could have them all, or you could have them all have their own. I mean, the good thing about presenters is they're extremely lightweight, and so having multiples might not be the worst thing as long as you're not, going crazy with it. Yeah. Yeah. Last question, because we're almost out of time.
How can you use this architecture in the service or something like that?
Sorry, say that again?
In the service, how can you use this architecture?
Oh, in a service. Yeah, that's kind of a whole other thing. So when you're exposing it to the background, this is kind of our model that we would use for the front end of things. I would probably have your service get connected through the controller some way, but it wouldn't necessarily be one of those components, I don't think. Maybe it could serve the role as a controller, but that's something I'll have to look into further. Yeah, it's a really good question.
That problem.
Yeah.
So I'm trying to fix it by exposing it differently, like a subcomponent of the system. It's not actually Android. It's different.
Well, we could talk more about that afterwards, because I've been working on something recently for like background location updates that uses a service that I'd be interesting to hear your thoughts on. All right, everybody, thank you for coming out. Have a great time.